let's get started. So if we were to solve this last week, we would write, subtract 4 from both sides, which is what we're going to do right now as well. So we'll subtract 4, and that'll give us x squared equals -4. Then we're going to go ahead and square root both sides, just like we did last week and the week before. However, today, instead of writing no real solution, we're going to end up with x is equal to, what is the simplified form of this going to be? What are you going to write for the square root of -4?
I times the square root of 2.
Yeah, 2i. Yeah, because the square root of 4, square root of -4 is going to equal the square root of 4 times the square root of -1, which simplifies to 2i. And don't forget your plus minus. There you go. So we're literally doing the exact same thing we did yesterday. We're just using it in conjunction with our solving using square roots method. But in terms of simplifying, we're doing the same thing we did to simplify yesterday. So the question right up here says, consider the equation. How many and what type of solutions would you expect? So anytime you're solving using square roots, generally you'd be expecting 2 answers. You'd have the principal root and the negative root. However, you're going to get the principal and negative imaginary roots today, as opposed to just the standard roots. Some of them will end up being complex numbers. I think we'll see some of those on the back, but at least for the first 2 on the front here, they're just going to be imaginary. They won't be complex. So let's try number 2 on your own, or try B on your own, I guess. So use the same process we did for solving by square roots, but then simplify with imaginary. All right, here we go. So for part B, we should get x is equal to positive and negative 3i root 2. Square root of -18, so we add 11 to both sides. -47 plus 11 is -36 divided by 2. -36 divided by 2 is -18. Square root -18, that breaks apart into the square root of 9 times the square root of -1 times the square root of 2. Square root of 9 is 3. Square root of -1 is I. Root 2 stays root 2, so we get positive and negative 3i root 2. Questions there? So the simplifying process is exactly the same as the simplifying process we used yesterday. It's just at the end of an equation this time, as opposed to just dealing with it right away. All right, go and flip it over. Let's finish this up. We got a few more problems on the back. I apologize for the misprint on problem number 3. This one right here is number 3. We'll go ahead and address that when we get there. So let's start up at the top here. So finding the zeros of the functions, it's the same as what we did on the front. It has to do with replacing f of x with 0 equals 4x squared plus 20. And then we'll just go ahead and go through our equation solving process. So we'll subtract 20 from both sides. So that would be negative 20 equals 4x squared. Divide both sides by 4. So that would be negative 5 equals x squared. So x will equal positive and negative I root 5. Don't worry about the check step. Any questions on that one? Positive and negative I root 5. Cool. 5 more problems, then we're done. Very quick day of notes. So lots of work time today, lots of work time tomorrow. Anybody need more time on this example? Okay, I'm gonna go ahead and scoot it. Let's take a look at number 1. I'll leave the answer up there. First of all, let's go ahead and translate number 3 over here, and then we'll cross it off from right here. So we're gonna have that'll be x minus 4 squared plus 2 equals negative 70. We'll put that over with number 3, and then we can just scratch that out right here. Okay. Does anybody know the answer already to number 1? Kind of see where this one's going. Positive and negative 5i. Yeah. Because we'll subtract 12 from each side. Negative 13 minus 12 gives us x squared equals negative 25. And then if we square root that, square root of 25 is 5, but because it's negative, we need the imaginary unit as well. So that'll be x equals positive and negative 5i. Nice. All right. Check out number 2. Subtract 22 from 6. What's that going to be? Negative 16. Good. So 2x squared equals negative 16. Divide by 2. X squared equals negative 8. Square root. And that'll be x is equal to positive and negative what?
2i.
There you go. 2i root 2. Nice. Which I think we had 2i root 2 as one of the answers on the first page of yesterday's notes. So if you forgot this one, you can actually check that list of problems we had on page 1 of yesterday's. All right. Let's check out the next one, number 3. This one is going to give us a complex number answer and not just an imaginary number answer like we've had so far. And it has to do with the fact that we have this binomial being squared. We're going to go through the same process we did to solve this. So we're going to subtract 2 from both sides. That'll be x minus 4 squared equals negative 72. And remember, we're not going to expand this square because this is a perfect square. So we can just go ahead and square root both sides at this point. It's underneath number 1, so we rewrote it off to the side. Yeah. So 3 got written underneath number 1 for some reason. So this one right here is that one over there. So we rewrote it and then scratched it out from underneath number 1. All right, so if we square root negative 72, I think that was on yesterday's notes as well. I think it was what? 6i root 2. Okay, so that's x minus 4 equals positive and negative 6i root 2. And we don't actually need the parentheses there. So don't write the parentheses on yours. So x minus 4 equals positive and negative 6i root 2. Now we have to write two short equations because we solved problems like this when we had positive square roots, and now we can do it with negative square roots as well, which will give us a complex number answer as opposed to just an imaginary number. So we're going to have x minus 4 equals 6i root 2. And then we're going to have x minus 4 equals negative 6i root 2. And we'll just go ahead and solve both of those by adding 4 to each side. And if you add 4 to 6i root 2, it won't combine with it because this one has an imaginary unit and 4 doesn't. So that'll be x equals 4 plus 6i root 2. And then the same idea over here. I'm going to separate those a little bit. Same idea over here. Add 4 to both sides. It does not combine with the imaginary unit because they're not like terms. Essentially, that's how we're dealing with it. And so we get x equals 4 minus 6i root 2. And you can leave them separate like this if you want to, or because we have the same leading value, that real portion of each of these complex numbers is the same number, and then we're doing the plus and the minus version, we can write it as 4 plus or minus 6i root 2. Now the answer for number 3. So this ends up being the only one with a complex number answer as opposed to just an imaginary answer. So I want you to work on 4 and 5. Go ahead and answer those real quick, and that'll be it for our notes for today. Nice and quick. And just a heads up, this is something that you might need to remember, and that is if you square root a fraction, square root the numerator, square root the denominator, and just write the answer as a fraction. If you need to, rationalize the denominator, but I don't think you'll need to. That's just a hint for number 5. How we do on number 4? 4 should have been the simpler of the two. What we get on number 4? Plus or minus I root 7. Cool. So number 4, x is equal to plus or minus I root 7. So you replace f of x with 0, subtract 7 from both sides, square root, get the imaginary unit out of there as I, and then the square root of 7 doesn't simplify. So that's number 4. And then the last one, number 5. Just going to go ahead and step by step through this one here. So first thing we're going to do, replace f of x with 0. So you got 0 equals negative 9x minus 1. Add 1 to both sides. 1 equals negative 9x squared. Divide by negative 9 on both sides. So that would be negative 1/9 equals x squared. And if you square root negative 1/9, or if you square root 1/9, what do you get? 1/3. And include the imaginary unit with that. So you're going to get x is equal to plus or minus 1/3 I. Because the square root of 1/9, or 1/9 is a perfect square, and it square roots to 1/3 because the square root of 1 is 1, the square root of 9 is 3, so you get 1/3. Get the imaginary unit out as well, so that would be 1/3 I. So positive and negative 1/3 I. Any questions? No? Yeah. What's that? Yeah. All right. We're gonna go ahead and call that a day for our note.